Okay, so let's talk a little bit more about this direction of processes. How I like to look at it is this. If we have, and I'm using an electrical situation here, this is again my very poor drawing here. If we have some sort of process here, this is my process, and I want it to be, this is an idea for a process, and this is going to be a real process. Okay, so if this is this side over here is an idea, and this side, if it passes all the way through here, it's real. It's got to pass through two switches. The first switch is the first law. That first law has to happen, has to sit down here and occur to make sure that process is possible. But it can't go all the way until the second law it satisfies the second law. Then it can become a real process. Okay? Then it can become a real process. So our perception, the things that we know, we have to now find a way to show this mathematically and through an equation. That's what we're trying to develop here. Why doesn't the ball jump back into our hands? Why doesn't the coffee cup heat up in a room that is a room temperature room? Why does a room temperature coffee heat up in a room temperature room? Those things we're trying to figure out. Now, there are numerous statements of the second law. It's probably one of the most widely cited laws out there. I said it before, nothing is perfect. Okay, we're going to understand why that saying of nothing is perfect comes out with the second law. Things only get worse. That's the second law. One of my students a couple years ago, it's been more than a couple years ago, were saying that we were talking about the second law and saying that their cousin, which was was studying to become a Catholic priest, was talking in their theology school about sin and the idea of the second law. And so if that happens to be your religious understanding, there's many different cultures, many different religions that often deal with the idea of the second law inside of their theology, not just Christianity. There's also other religions that bring that up. Okay, in economics, there's an idea. There's a study called ecothermodynamics, where you're talking about how the movement of money occurs and how that second law can affect it. I often follow something called the second law of teaching. In fact, I've given a lecture about it one time in a kind of a TED Talk way. That you come up with that perfect way of doing something, and just because of the way things work, it's never going to be exactly as it worked out. That you think something's going to happen. There's all these factors out of your control. It's going to happen. The heat death of the universe. These things are tied into the second law. I encourage you to, if you have some time to have a good read about the heat death of the universe. And all these ideas really come up to this idea of entropy, and we're going to be developing entropy in this chapter, but we're not really going to be saying the word specifically as much as what I would like to. So I like to introduce entropy to you right now, because that's something that usually students have a difficult time understanding. What is entropy? You know what energy is, but you don't know what entropy is. So let me this is my best way to explain entropy. Every process that occurs in this world develops entropy. It gives off entropy. Okay, it's generated in every real process. This is the idea that connects all these theories together. Okay, every process gives off entropy, generates entropy. You can't have a process that absorbs entropy or lowers the entropy of a situation. Entropy is not conserved, it's always given off. So that's how we know a direction of a process. That's how we know if processes are possible or not. Do they give off entropy? That's going to be our deciding factor. Okay? Now, entropy in the second law help us it's sometimes called time's arrow. We know that time moves in a certain way, and it moves in the way where entropy is generated. Okay? Now here's how I think of it in my analogy. because I have 2 kids, you know them. If you put sand in your hands, and as you are trying to carry that from place to place, the best you can do with that sand in your hands is end up with the same amount of sand that you start with. As you walk to wherever you're walking, you'll end up with that same amount of sand. That's the best you can do. That is a perfect situation. Okay, the second law allows that to occur, that you can have a perfect situation. I can move from here to there, and then the amount of sand in my hand, the amount of entropy in my hand will be the same, state 1 to state 2. That's the best that can occur. In no situation could I just have more sand come in my hand. How did that occur? That cannot happen. That is not possible. Okay. But what's a real process is going to happen is as I'm moving from place to place, that sand is going to fall out of my hands. I'm going to leave it on the world. And that's kind of where I'm talking about the generation of entropy. The limiting factor is that no entropy is generated. There's no possibility that the sand's going to come from the world up into my hands and put more in there. But the highest likelihood is what's going to happen, because it's hard to hold on to sand, is that some sand is going to come out and sprinkle on the world, and that is going to be that generation of entropy. Now, some processes that we are going to develop are going to be very, very good. They're going to be close to that process where we're not leaking out any sand out of our hands. And some processes are quite frankly going to suck, that all the sand is just going to fall out of our hands. We have a very poor mechanism, and we're going to generate huge amounts of entropy. Our job as engineers is to try to create processes that do not violate the second law, and they do so by generating the smallest amount of entropy. Okay, that is what we're going to do. So we're going to circle back to this idea multiple times, but I want you to hear about it now and think about it now, so that when I give you the equation for it and I bring up this analogy again, that you understand it. Okay? All right. So let's talk about the transfer of energy, okay, and the conversion of energy a little bit now. And let me stop it right there, and I'll start the conversion of energy in another video.